47 years ago, Voyager 1 took this photo of Saturn's largest moon, Titan. It was the first close-up we had ever seen of this strange world. And there in the distance were mysterious dark spots that scientists would later determine were lakes. Today, we know that these lakes are made of hydrocarbons like methane and ethane. And yes, I said lakes. All the evidence tells us that besides our own Earth, only Titan has liquid lakes and rivers. I think it is safe to say that most people don't spend much time thinking about what's on Saturn's moons. I certainly didn't until I started working here at a science channel. But when you start looking into it, there's so much wonder to uncover. Like, how could lakes exist on an alien moon? How are they formed? What's the weather like there? And is there any chance that someone or something might live in them? We're going to answer all those questions and more today because these lakes are fascinating and could help us find life beyond Earth. Now let's get into it. So yeah, that image was taken by the Voyager 1 spacecraft back in 1980. At the time, scientists couldn't quite figure out what was going on with those dark spots. Were they solid? Were they liquid? Were they even real? Some scientists even thought they could be dry ground, kind of like sand dunes. But that mystery was solved just a few years later when the Earth-based Arecibo radio telescope observed what appeared to be waves rippling across the surface of one of the lakes. And that suggested that they were definitely liquid. By 2004, when NASA's Cassini spacecraft arrived at Saturn, we were pretty sure that these dark spots were lakes, but we weren't sure what they were made of. When Cassini began taking pictures, we got our first close look at these lakes, and we learned that they were filled with a type of ice that can remain stable at around negative 180 degrees Celsius. This ice is mostly made of hydrocarbons such as methane and ethane. These hydrocarbons rain down from the upper atmosphere and then freeze on the surface. The reason why this happens is complex and involves a lot of atmospheric chemistry. But it all boils down to the fact that Titan's atmosphere has a lot of methane in it, which is unusual for a rocky body. We think that this is due to some sort of chemical reaction between Saturn's atmosphere and the organic molecules spewed out from the many active volcanoes on its largest moon, Titan. Methane is also a byproduct of volcanic activity on Earth. On Titan, though, the methane makes it all the way to the surface without breaking down, and instead creates a thick, cloudy atmosphere that rains down hydrocarbons onto the surface, forming vast lakes and even bigger seas. In fact, there's one sea on Titan that's bigger than all of the Earth's oceans combined. The presence of these lakes told us a lot about Titan's surface. Scientists realized that the ground underneath them must be solid since the ice wasn't just floating on air. It was resting on something denser. That's why they used radar to map the subsurface structure beneath the lakes. They found that the ground is about half a mile deep, much like Earth's crust. Below that is a layer of rock and ice about 30 miles deep. And below that is a liquid ocean of water, which is probably where all the water on Titan went. So far, we have found 5 lakes on Titan. 3 of them are fairly small, while the other 2, known as the Kraken Mare and the Hydrocarbon Mare, are much larger. We think these lakes came into being over billions of years. As the icy ground below them cracked and shifted, pockets of the liquid ocean below froze over and created hard ice sheets. Eventually, those sheets became so thick that the pressure from the ocean below was no longer enough to keep them melted, and the lakes were born. The hydrocarbon lakes are located near Titan's poles, which are always shrouded in thick clouds and storms. Most of the precipitation falls here, so the lakes never seem to freeze over. But it's not all sunshine and rainbows. Sometimes the lakes freeze over, but not in the way that we think. You see, although the lakes themselves don't freeze, the surface of the lakes do. This creates an ice sheet that covers the entire surface of the lake. But as the temperatures rise during the northern hemisphere's summer, the ice melts and forms a hole in the middle of the lake. Because of this, Some parts of the lake may appear frozen, but if you look closely, you'll notice that there's a big hole in the middle where the liquid is still visible. Now, some of you may be wondering, how does anything stay liquid at those incredibly low temperatures? Well, it's all about pressure. The pressure at the bottom of the lakes is so high that it keeps the hydrocarbons in a liquid state despite the freezing cold temperatures. In fact, the pressure at the bottom of the lakes is about 150 times greater than the pressure we experience at sea level here on Earth. And don't forget about the winds. Storms on Titan can whip up winds that are twice as fast as Hurricane Katrina, which is one of the most powerful hurricanes that has ever hit the United States. But if they're so volatile, how is it that the lakes stay so still in the photos? Well, it's because the photos were taken during the calm season. The lakes aren't always calm, and the winds can pick up so much that it's impossible to see the lakes clearly through the clouds. Now, because Titan has a dense atmosphere, these lakes can't form large waves like we see on Earth. However, they can form smaller waves called capillary waves. Capillary waves are caused by the interaction between the surface tension of the liquid and the forces of the wind. Because the surface tension of liquid hydrocarbons is so strong, they form very small waves that are only a few millimeters high. The waves can travel very fast, though, and can reach speeds of up to 60 meters per second. Another thing that scientists have noticed about these lakes is that they seem to be getting bigger over time. Since the discovery of the lakes, we have seen them grow in size, and we're not exactly sure why. One theory is that the rising temperatures are causing the ice beneath the lakes to melt and add more liquid to the surface. Another theory is that the lakes are slowly draining from their source and becoming bigger as they go. Either way, it's clear that these lakes are dynamic and changing over time. Now, if you're still watching at this point, I have to ask, how cool is this? We have discovered lakes and seas on an alien moon made of stuff that doesn't exist on Earth in this state. If we can discover this much about Titan, imagine what we'll find when we explore bodies that are more like Earth. As for whether or not anyone lives in these lakes, we really don't know. But it is a possibility. Life as we know it couldn't survive on Titan. There's too much methane and not enough oxygen. However, that doesn't mean that life couldn't exist there if it evolved under completely different conditions. After all, life on Earth exists in some of the most extreme environments imaginable. There are animals that live in boiling hot springs, others that live in the frozen wastelands of Antarctica, and others that live in the crushing depths of the ocean. So who's to say that life couldn't evolve on Titan to live in the hydrocarbon lakes? If life did evolve on Titan, it would almost certainly be very different from life on Earth because of the lack of oxygen. Any creature living in the lakes would have to rely on a different source of energy. Perhaps they would be powered by the sun, like plants on Earth, or maybe they would be powered by the heat from Saturn, like the creatures that live in the deep ocean trenches. One thing is for sure, though, any creature that lives in the lakes would have to be perfectly adapted to the environment. The temperature is far too cold for most life forms, and the pressure is far too great for most others. In conclusion, Titan's lakes are truly fascinating. They are a reminder that our universe is full of wonders that we can only imagine. Who knows what other secrets Saturn's moons are hiding? With future missions to Titan and other moons, we hope to learn even more about these incredible bodies. And while we may never find life on Titan, the search itself is what will lead to new discoveries and a better understanding of our place in the universe. Now, if you want to learn more about the search for extraterrestrial life, check out this video. Thanks for watching.